All right, let's work with a couple of examples, see how things look with this equation. So the first one here I want to work with is, let's say a temperature in Celsius, we're going to use a little c for that, is a linear function of the temperature in degrees Fahrenheit. We're going to use a little f for that. The boiling point of water is 100 degrees Celsius, and if you didn't know, in Fahrenheit it's 212 degrees Fahrenheit. The freezing point of water is 0 degrees Celsius, and for Fahrenheit it's 32 degrees Fahrenheit. I don't know why Fahrenheit exists, it's really annoying, but we're working with that. Write a linear equation to describe or represent this function. Well, where do we even start, right? Well, we know it's a linear function of some sort, so we could use slope-intercept form, or we could use slope-point form to solve this. Now, slope-intercept, we need to know what our slope is and what our intercept is. I don't know either of those with the information that's given to me. For slope-point form, I need to know a point, and I also need to know my slope. Slope I don't know, but I can probably figure that out because I have enough information here to tell me where my point is, which means I have my point. So slope-point form should work with this equation, and we're going to work through that and see what it looks like. Okay, so the first thing I'm going to do, you don't have to do this, but I'm going to re-record some of my information just so that it makes more sense to me. The two things that I'm recording are my points because that's what I want. I have a boiling point, which is 100, 212. I have my Celsius coordinate first, my Fahrenheit coordinate second, and my freezing point is 0, 32. The next part's kind of interesting. Well, it's interesting to me, maybe not you as much, not yet anyways. We're going to start off by writing our equation, which is y minus y1 is equal to m times x minus x1. And then we're going to plug some of our information in. But before even doing that, you might recognize that we still don't have our slope. And we got this equation by rearranging the slope formula. So why don't we just solve for slope? And you're not wrong. You can do it either way. You end up solving for slope either way. So I've solved it for slope. I've rearranged this equation for a slope formula. Then I plug my numbers in for my y2, my y1, my x2, my x1. And I end up getting 180 over 100. That's a fraction that I can reduce. I've done this equation a million times, so I can do it fairly quickly. You might need to punch it in a little bit and your calculator, for example, to help you with a fraction until it becomes common knowledge. If you know conversions, Celsius and Fahrenheit, you might clue into that fraction a lot sooner, but if not, it's okay if you get to 180, 100. Why is this important? Well, now we have a slope and we have enough information for points that we can actually go straight to the solution without doing any more of the hard work. It looks like this. Simply, we go back to our equation because that's what we're solving for in the first place. But now we have a slope. We can plug that slope directly into our equation. We have y minus y1 is equal to 9/5 of x minus x1. And now you get to choose. Which point do you want to use? Boiling point or freezing point? Doesn't matter. You end up getting the exact same result. I'm going to choose freezing point because it's got a 0 in it. Nicer numbers give you a nicer equation. So my x value is 0. So my x1 is going to become 0. And my y1 is going to become 32. I'll clean that up so it looks a little bit nicer for you. Just like that. So y minus 32 is equal to 9/5 of x minus 0. Or if you ended up choosing your other point, if you chose the boiling point instead, you get another equation, but it gives you the exact same equation of a line. Y minus 212 equals 9/5 x minus 100. Don't believe me? Head back to our Desmos video if you haven't checked it out just yet. If you do have it on your app, plug this equation in, and you'll realize you end up getting the exact same line because they actually are the exact same equation.